We're back again with another video. Basically, in today's video, we're going to focus more on integration. Furthermore, under integration, we got indefinite integral. What do we mean by indefinite integral? Technically, it's the integral which is not defined over a certain variable, and we denote that by adding an arbitrary constant c. Alright guys, let's pay close attention. We have this formula: x to the power n dx equal to x to the power n, and remember we should add 1 to the exponent n, then we're gonna get all divided by the exponent n plus 1 plus the arbitrary constant c. Okay guys, let's have few examples. We have integral x to the power 2 dx equal to, comparing these two, in our case here, in place of n we got 2, meaning that we will say, because n is 2, we will have 2 plus 1 all divided by 2 plus 1 plus the constant c. Okay, let's answer this one. We got x to the power 2 plus 1 all divided by the exponent 2 plus 1 plus the constant c. However, this could be written as x to the power 3 all divided by 3 plus c. For instance, we have the integral of x with respect to the variable x, meaning that to integrate x, remember here we got exponent 1, meaning that in place of n, this time we will replace n by 1. Then we're gonna have x to the power 1 plus 1 all divided by the exponent 1 plus 1 plus the constant c, which can also be written as x squared all divided by 2 plus c. We are integrating with respect to the variable x. However, here there is no x. This can be written as int 1 dx equal to, we have to transform this to int x to the power 0 dx. Guys, we wrote this because 1, okay, x to the power 0, it gives 1, so that now we can be able to write in this form x to the power n plus 1, where our n is 0 plus 1. Then let's quickly write it. We have 0 plus 1, all divided by the exponent 0 plus 1 plus the arbitrary constant c equal to, okay guys, This can also be written as x to the power 0, 0 plus 1 equal to, we can write this in terms of same base multiply, we add the exponent, then we were gonna have x to the power 0 times x to the power 1, and we know that this is the same as 1. Remember, any base raised to the power 0 gives 1, then 1 times x, we're gonna get x, meaning that in place of this term x to the power 0 plus 1, we will replace it by x. However, on the denominator we have 0 plus 1. 0 plus 1 gives 1. X divided by 1, we're still gonna get x, meaning that here we will be left with x plus the constant c, just like that. If we have to integrate 2 with respect to the variable x, however, this is more like this one, then we can just write it as 2x plus the constant c. Okay, let's conclude today's lesson by derivating this one. If we derivate this one using this approach, we're gonna get int x to the power root of x is x to the power half, then we're gonna get 1, we're gonna get x to the power half dx. However, our n here is half. Let's replace n by half plus 1. Then we will get x to the power half plus 1 all divided by half plus 1 plus the arbitrary constant c. Okay guys, half plus 1 is nothing but 3 over 2 divided by 3 over 2 plus c equal to, we can write it as x, or we can simply write it as 2 over 3 x to the power 3 over 2 plus the constant c. Plus the constant c. That's it for this video.